Let's take a look at how subnet masks are used. We'll also explore why both physical MAC addresses and logical IP addresses are always needed for communication. Let's do all of that with a couple of stories. In story number 1, host A, with IP address 10.10.1.1, wants to communicate with host B, whose IP address is 10.10.1.2. The source of the traffic will take its IP address and subnet mask and perform a Boolean AND operation. All 32 bits of the IP address are lined up with the 32 bits of the subnet mask. In this case, the subnet mask of the source, 10.10.1.1, is 255.255.255.0 in base 10. In binary, it looks like 24 ones followed by 8 zeros. This means that the first 24 of the 32 bits are network bits and are shared by every device on this network. The last 8 bits are host bits and are unique in entirety to each host on this network. Each of the 4 base 10 numbers is known as an octet because each number is represented by 8 bits in binary. Subnet masks can span multiple octets and need not be contained to a multiple of 8 bits. For example, instead of 255.255.255.0, the mask could have been 255.255.255.192, where the first 26 bits are network bits and the last 6 bits are host bits. When the host logically ANDs each of the 32 columns, bringing down a 1 if both bits in the column are 1s, and bringing down a 0 if the 2 bits in a column are not both 1s, what results is what we call a network identifier. In this case, the source's network identifier is 10.10.1.0. No matter how many host bits are in an IP address, if they are all zeros, that represents a network ID and cannot be assigned to a host. In this case, there are 8 host bits, and they can't all be zeros, because the IP address with all host bits set to 0 represents the network ID. In fact, they can't be all 1s either, because when all host bits are set to 1, that represents a network broadcast address, and like a network ID, cannot be assigned to hosts. This network's broadcast address, with all host bits set to 1, would be 10.10.1.255. Any pattern besides all zeros and all ones for the host bits, that's legal and valid to be assigned to devices on the network. Now, the source needs to determine if the destination is on the same network or a different one by performing a second Boolean AND operation. The source takes the destination IP address and logically ANDs it with the source's own subnet mask. The destination's subnet mask is unknown, and it is never transmitted. The destination's IP address is either known by the source or resolved from its name using a protocol we'll explore in a future module called DNS, Domain Name System. The source doesn't actually need the destination's mask because if they are on the same network, their subnet masks will be the same anyway. After logically ANDing the destination IP address of 10.10.1.2 with the source mask of 255.255.255.0, the resultant network ID matches the network ID of the source, 10.10.1.0. This lets the source know that the destination is on the same network, and traffic can be delivered directly.